Okay then, it's official. It works until up till 1 trillion. And it spanned 30 threads. That's long on the row zero, on the row 0. As that it spanned with 1 thread on the next 33 rows. Only 33 rows? That's bullshit. That's way more than that. This number's wrong. Let's check if this is correct, however, because... Is it? Please let it be correct. Where's my... See, this is way, it's way larger, isn't it? It's just not correct. Is it correct? It's correct. Oh yeah. 89. Yep. It works till 1 trillion. Very good. Yep, okay. Let's... This will go 40 minutes. 40 minutes. That's not even that much, dude. Okay, I wonder if I can just collect a bunch of primes and then do the sieving. Yeah, I'm going to do something else. Yeah, I don't know. It's definitely possible to improve it further, but at the very least, I think I want to do a git commit now. Let's say debug. I should commit it first before I make more changes, damn it. Let's just commit it, even though... One point bloody 8 seconds. Why? It gets slower and slower, this thing. I don't get it. Yeah, I wanted to commit it. Just commit it, man. Get diff. Do this stuff. Whatever. No, no. What? this. Yeah, .git modules. I didn't see a div there. Shit, looks good. What's wrong with that? What happened? I don't know. Whatever. No debug output. What the hell is going on here? Yeah. Hello, Cooling Gem. Yes, it's public. I just showed. Oh, you want the fast primes thing? It's this one. Oh, that doesn't help you maybe, but it's just https://github.com/ and then that. It's on GitHub. Well, as you can see there, but this is not an URL. If you replace that with the HTTP stuff, you'll be able to find it. Well, Atkins 3 used to print a lot of stuff, and now suddenly it doesn't. Why not? I mean, it did not print this. That has been commented out before. And I don't see any other. See out. Oh, here, yeah. Yeah, this. That's what should be printed. But apparently it's not printing it. Because we never get here, past this point. Why? This is not good. So it works for a billion, but not for 1 million. Is that it? 1 million. Let's try small values then. 1, 2, 3. Make nth prime. It does work. It works, so why is it not working? We should get past this point. Completely. Oh, maybe it doesn't get past the make vector. It would be broken then. Okay, well, let's do standard cout running make a vector. And then standard cout done. Nope. Nothing. I have so no idea what is causing this. Why would Atkin 3 hang here? Or where does it hang? But where does it hang? How is that possible? How is that possible? Cooling gem, yes, yes, yes. Well, I already did. I'm now testing why this is not working. Well, threading was added. You see, let me show you the problem here. This function here, sorry, this program here, nth prime, if I run that, it works. Okay, so it just prints out the correct output. If you look at it, the main function here begins with well this and that works as you could see. Maybe it's slightly different from the other one because most notably I was thinking this is 1 million, so it generates all primes up till 1 million using a handler from the threadpool where that uses 30 threads and the queue size is 90. And the other one, Atkins 3, is not working, so there must be a difference. Now I'm not passing 30 here, but maybe more importantly I'm not passing, the capacity is less than 90. It is 1 million, I'm pretty sure. It doesn't matter if that is UL or not, because it even fits in an integer. It must be the capacity. So if I make this 90, then I expect Atkin to work as well. Yep, all quadrums, but at least now it's done. This is bad in itself. Why on earth would suddenly his prime be broken again? Ugh. Now I have two things to look into. Let me make it 1 billion first. Okay, that just remains. So that's not a problem. 2, 3. Putting 30 here shouldn't make no difference whatsoever. Let me try threadpool of 4 threads. It will be almost as fast in the beginning and then still course. And then if I try to use capacity of 32 as I had before, does it still hang? Oh, does still hang. Well, that's interesting. Let me think about that. Why that happens. Let's use nth prime. So it's my main go-to for debugging this over. If I make this 32, whatever, less than 90, then, and I also make 4 threads because 30 threads is way too much. So now nth prime is also hanging. Oh, it's just a test that I just started, but at some point I'm going to concentrate on the sieve of Atkin instead, as opposed to the sieve of Eratosthenes. Everyone knows the sieve of Eratosthenes, but the sieve of Atkin is from 2003. It's 2,000 years later than Eratosthenes. It would have been, it should be some kind of improvement, but I just want to analyze it and understand it. And I was using the atkin.cxx file to start to do tests started to research, say, so I would understand how it works. But then I needed a working primes generator. So then I went back to my prime generator, and I'm trying to finish it now. And then once my prime generator completely works, then I'm going back to looking at Atkin. Now, the reason that I'm running it is that the Atkin is a different algorithm that generates numbers that should be primes in a different way. And then I call is prime using my prime generator. While nth prime is not calling is prime. So it has two interfaces. Primes has two interface functions, or main interface functions. One is next prime, which returns every time the next prime, and the other one is prime, which returns true or false, depending on what you pass is a prime or not. So nth prime is testing next prime, and Atkin is my go-to currently to test is prime. So because of the Atkin 3 test thing is failing, that means that my prime generator's is prime method is not working anymore. And on top of that, it's hanging if I use less than 90 for the queue size, the thread queue size. And I want to look at into the hanging first. So let's fast primes / primes. Let's see XX. So oops. You get here. If this is true, then we found the next prime. Which is what the hell? Which is this thing then? So we are in row 0, and we only run over all columns. I have a 2-dimensional sieve-ish. Therefore, row is 0 and column is column, and then this function returns a prime that belongs to that. And that structure just takes that prime as the parameter of the constructor here. So we pass the prime that belongs to row 0 column to the constructor, which then initializes this prime with the current prime, and as well calculates and stores some other variables like offset and compression, primordial inverse, which is all depending on the prime. We also store in an atomic the words per row, which is 90 at the moment. So if my queue is less than 90, then what happens? Now we're going to run here, so it's still the main thread. This loop is 90 big, and that logs the MQs of the thread pool, gets read access. Get a reference to the queue. Then we get producer access to that queue, so we can write to it. Then we ask what the current length is of the queue. So then the length is just a number of tasks that are already in the queue. And if that length equals capacity, then the queue is full. And it will run full because this loop is 90 big, while the queue is currently 32, has a capacity of 32. So we're going to loop and add new tasks, and we do that 32 times, and the 33rd time we're going to run in the fact that length is equal to capacity, because I'm going to assume that adding new tasks is way faster than any of those tasks finishing. So at some point we get that the queue is full. But okay, then initially, let's follow this. Initially, of course, the queue is not full. And then we say, well, we got write access to the queue. And we say move in a new task. And if a task is added, then by the time it finishes, it will decrement running tasks with 1. So if we add exactly 90 tasks, then only when all 90 are finished, running tasks become 0, and that's what we are spin locking on here. But at some point, because now I made my threadpool queue shorter than 90, it's going to run full at some point, and then we skip this because that if is false. And then we leave a scope which release, or this scope I think, to release the produce access. So another thread can write to the queue again. So we are the only thread that writes to the queue, so it's kind of not important. But it would be a destruction of this object. And then we call, this function must be called every time move in was called on a queue that was returned by threadpool queue. So if a queue is not full, then we did call move in. And because we called move in, we must call queue notify 1. And now we get here, the queue still being full. Go to the top. Oh! Oh, what? So it's not reacting at all. What? This is just the loop to the top, so it's going to the next word column. What about my task that failed to be added to the queue? Yeah, that's bullshit. So if the queue is full, then we do not attempt to add the task, but we just continue. So we just not execute that task. And yeah, then if the task never runs, then it will never decrement that 90. And therefore, we'll wait indefinitely in the end. I would have expected that the one that was left over to be much larger even then. It's even a miracle that's only 1. Okay, so how should we react then when the queue is full? Let me look at threadpool docs, if we have that. Yeah, this is the code that I copied. And it's just ignoring everything. Just, well, it's not talking about what happens when the queue is full. Queue not full, add it, and otherwise don't add it, and don't call notify one. And then we are here, and we didn't do anything. but well, I guess I need to look at some real code that is using the threadpool to see how that is dealing with this, with the queue full problems. I think it was something like, yeah, this is something for it. I just don't know anymore what it was. New tab. Which is using the threadpool. You should say I don't even have a threadpool test suite, so this is the only thing I have, I think. Unless you count Linux Viewer. I'm not sure if that's even, I don't know. Right. So I should have this code somewhere. Q notify one. Or I could look at move in maybe. So somewhere I'm calling move in. Where's my move in? Here, move in. I can just look at move in, I think. Grab project sources, move in. PRS not found. Yeah, just grab all sources. Okay, the EVIO as the event loop thread uses it. Object queue. Thread pool. Source threadpool.cxx. That might be a test. There's a comment that I want to read. If this happens, then you did something wrong. It says only call queue notify one when you just called queue access move in. For example, if the queue is full, so you don't call move in, then also don't call notify one. Okay, I'm not. Looking at the threadpool itself first. Here's another one that says, talks about PA move in. Okay, that's okay, that's when the task is still active. It says is there room in the queue? If so, then just run the task again, but it's put at the back of the queue. Otherwise, it is not on. It's like ignored. Oh, wait a minute here. If put back, no, queue is still required. Not really understandable. Yep. Let's look at that one. Okay, well here we have something. So the buffer full in this case looks like queue full, but okay. So this is queue full, and if the queue is full, then length equals capacity, and therefore it's not less. And therefore we skip this. And then we get here, and then this code happens. Oh, big code. So the threadpool queue is full, cannot run. Yeah, that code is missing then. We should add something to the threadpool that executes task multiplex normal run handler. But we can't because the threadpool queue is full. Pass it to the magical function defer instead. Boost intrusive pointer task this, stop the responsible parent task event, if any. Yeah, this is stateful task stuff, which is also a magic code. Threadpool defer. This will call the lambda after a while. Maybe that's what I should do then. Yep. So threadpool itself has a defer. And if the queue is full, the queue handle is full, then we call defer queue handle failure count, and then a lambda. That if it is called, yeah, adds the task to the threadpool, but we don't have a task like that. This is a AI stateful task. Yeah, okay, cooling gem. I'll see you. Add task to threadpool. I don't want to drag in AI stateful task. I mean, I know that works, but maybe I should just look at the defer thing. It's in the end what it is. What else do we have? Object queue. Here's a threadpool test. Let me look at that. I don't like the idea of to sleep. So it says entirely processed, but what it's really doing here, I think, is if the queue is entirely full, well, that would be here then we sleep 1 millisecond. And if then that was the case, and then we try again, and as soon as the length is less than capacity, so it's not completely empty, it's just not completely full, then we squeeze in a call to. Oh, that's how. Okay. So it is loops, sleeping 1 millisecond every time until there is at least one spot in the queue that we can fill with this lambda here, which we'll call finished open. And because that is moved into the queue, well, after everything else, then we can just wait here for the finish to be called. So it kind of waits until one of the tasks is finished and then squeezes in a task that will open the gate. It's a gate. And then we wait for the gate to open. So that means that then indeed the whole queue that every task that was in the queue at this point has then been processed. Yeah, but sleep a millisecond might be a bit too much. Okay, but I could still I could add a spin lock here on reading the capacity, the producer access, the length, I guess. Yeah. So make this a spin lock and just not sleep, or do a CPU relaxer. That would work, and then we wait indeed until the whole queue is finished, and then we could continue with adding stuff. So this block would work. This block would definitely work. The downside is that you want to keep all threads occupied, and if you wait till the queue is completely empty, then yeah, you just start, say, the first thread finishes, and then the next thread finishes, and the next thread finishes, and in the end you only have one thread running, which is maybe running longer than the rest, and all that time you're not even adding new tasks. So I don't like that idea. I would rather add a new task as soon as the previous task finishes. In other words, it's not nice at all to have to do this. What was I saying? I meant I could wait till, say, the queue is half empty, but then you cannot use this method. Yeah, I'm spin locking anyway. I can just spin lock until, say, it's half empty, and then begin again. But how? No, not really. Actually, no. I think even half empty would mean that half of the threads wouldn't be doing anything, wouldn't it? So that would work. It would work if the queue is significantly larger than the number of cores that you have, or the number of threads that you can run. So I have 30 threads, so I could make the queue 60, and then when the queue is full, wait till it is half full. So that moment, at the moment that the queue is, no, it's not true. That's nonsense. Of course, sorry. It's nonsense. Whatever is in the queue is not running. So I can definitely wait until the queue is empty. So every thread that has nothing to do will get a new task from the queue. So as long as there is anything in the queue, even one thing, then all threads are still running. So maybe I should do this one. Because that takes a little bit time, maybe one thread could be left. Maybe I could spin log, because I'm spin logging anyway. On, let's say, until there is only one thing left in the queue. So I do have to do this then, and then make it spin log. It is an idea, and that's in source threadpool. I want to look at the other possibilities though. What is this object queue? No, it's just pure interface testing. That won't be very useful. And then the event loop thread, yeah, that's finished code as well, so that would be useful to look at. So here queue full. If queue full, queue access wait. That's a new one. Wait until queue access notify 1 is called. I didn't even realize that one existed. Well, that's definitely another possibility, huh? So this is wait on queue access. And what is queue access? Queue access is whatever producer access returns, which is producer access. Producer access has a wait. Here's the wait. The lock is already locked when entering, so adopt it. And buffer full wait. Producer length of less than buffer capacity. Yeah, that literally waits until there is new space in the buffer. Using this would be the perfect function if you want to not spin lock. This wait is condition variable. So and buffer full is a condition variable. Yep. AI object queue. Well, debug queue was full, but it's just debug code. So what it really does is do a do loop, queue length test if the queue is full. If it is full, call wait. Otherwise, we do a move in. Output events, there's also a move in. And we're there while queue full. So if the queue was full, then we just return from that wait. And then we go to the top and try it again. Which starts with, so the do while loop is around the call to queue axis length. I'm going to do that one, I think. Let's try that. Queue axis length, queue axis wait. So the do was here. Yep. So lock get producer access and then keep that locked. Well, that should not be a problem in this case, I think. Depends, of course, but well, we are being very greedy. If not queue full, so then here I want to do while queue full, right? This is the while queue full. Yes. And then if the queue is full, we must call that access wait. Queue access wait. No, what is this? I'm missing a brace. Everything has to be indented. If not queue full, okay, I can do if queue full and then call that function. Yeah, okay, so now it doesn't skip it. It just hangs here and then tries again until the queue is not full, and then we call move in. So now it cannot hang anymore. Yep, that worked. Let's see if we can find out if it got slower or it gets slower. So first I have to time it again with a queue that is large enough. In debug mode, not in debug mode, I mean release mode. Comment is out. Resource configure make. On the test. Half a second for up till 1 million. Gotta be kidding me. Yeah, I have to increase this a bit. Yeah, let's do 10 billion to have a reasonable timing. And 10 seconds. I'm gonna run it again. See how reproducible that is. Very reproducible. Oh, 10 seconds, of which 4 seconds just reading out the sieve. So 6 seconds to generate it. And that was with a very large capacity. If now we make the capacity third of what you want to add, then what happens? Suckage. That's way more than 10 seconds. If it returns at all. I think it hangs. Great, now it hangs, so it doesn't work. Nope. Seems we never returned from this. Or would it still be that we never reach 0? What is Atkin? Yeah. With all the debug output, it's not hanging. Yes, it hangs. Yep, they're all dead. Interesting. The main thread is waiting here. And all other threads are already finished. Yeah, nobody's calling a notify one, I guess. Then, so data here is, oh, the running task is 18. It says. Okay, so it still has 18 more to do, but it's not waking up, so it's not going to add those 18. Why is it not waking up is the question. Now, well, because notify one is not called. So who should be doing that? I guess every thread that is finished. I think notify one is extremely slow, however. Yeah, I had a bug. I have a bug report about that somewhere. I can't even remember the project that it is in. Didn't I see this recently? Let me try to find this. This should find anything. Type F, execute, grab. No, just name. I think I know the name. The name has the word bug in it. And ends on dot, I don't know. A little bit too much. Wait, that's not true. Oh, debug, yeah. Hello. Epoll bug. Oh, that's something else. Yeah, that's the one that I saw. Epoll has also incredible delay. Well, it should not have. But that's the one I meant, so I don't have a test for it. It is not that I remember, but I do remember that I have something on Stack Overflow. So if we go to Stack Overflow, yeah, well, find that. I think I said somewhere something like, oh, notify one and slow. Hope that the search is good. Notify one slow. Nope. I think it was a question of myself. Let's be able to find that. Answers, questions. What is the all questions? No, I don't see it. Oh, that's next. No, that's the one. Is the performance of a Notify 1 really this bad? Yeah, and then I have to read everything to understand. No answers. Let me read what I wrote. For the measurement below, I've been using The full source code can be obtained here, which is independent of other libraries. That's compiled with. What I really try to do is measure how long it takes to execute a call to Notify 1. When one or more threads are actually waiting relative to how long that takes when no thread is waiting on condition variable, on the condition variable used. To my astonishment, I found that both cases are in the microsecond range, which is when one thread is waiting, it takes about 14 to 20 microseconds. When no thread is waiting, it takes apparently less, but still at least 1 microsecond. Najib Ahmad, hello. Do I know you from Brazil? Peter D. Royce from Brazil. Oh, also hello. In other words, if you have a producer-consumer scenario and every time there is nothing to do for the consumer, and you let them call wait, and every time something new is written to the queue by producer, you call notify 1, assuming that the implementation of standard condition variable will be smart enough not to spend a lot of time when no threads are waiting in the first place, then, oh horror, your application will become a lot slower than with the code that I wrote to test how long a call to notify 1 takes when a thread is waiting. It seems that the code that I used is a must to speed up such scenarios. And that confuses me. Why on earth isn't the code that I wrote already part of standard condition variable? The code in question is, instead of doing producer thread, add something to the queue, call notify 1 on the condition variable. So note, this is, in our case, the end of the task. So every task executes something and then it should call notify 1 at the end, right? And the consumer just, well, they called queueaccess.wait, which does something like this. Some condition and then it waits. So instead of doing this, you can gain a speed up of a factor of 1000 by doing produce a thread, add something to the queue, int waiting, while waiting is as idle, load, memory relax larger than 0. If compare exchange week, waiting -1, everything relaxed, continue. Unique log, notify 1. Consumer empty, unique log, fetch, add, wait. Okay, so the difference is that instead of doing this, we insert this add here. So we have we have a boolean that marks 2 other threads that we are waiting, and we do that inside the log that belongs to it. Right. So if I just call wait, then I can't do that. Maybe I should add that then to the to this wait function that I wrote, because it seems important, right? Okay, I can add it. So then we have an idle atomic that is incremented every time we enter the condition variable wait, and we do that while the log is taken. And then instead of just calling notify 1 regardless, we check if anyone is waiting at all. If nobody is waiting at the moment this is being called, then we don't call notify 1. Why does that feel like a race condition? I don't get it. It seems like a race condition. You could read this variable, get 0. And then before this thread is doing anything else, this thread just logs at mutex, adds something, enters wait, and now enters wait. So it's going to want to see a notify 1. But this thing already did read 0. So it's going to say, well, 0 is not larger than 0, so we do not do anything. Well, I would say it's just completely a race condition. I don't see why this would be correct. You can't do that. Hey, Nick de Nico, how are you, man? Well, I'm open for to feedback from any people on the chat. Should I make it larger because this font is maybe a bit smaller? So this code, the idea is that if the queue, here we are talking about something else than what I'm doing, but the idea is the same. We have a condition variable and some thread is calling wait on it. And the other one, another thread then must call notify1 to wake this one up. So what you want is that if the condition is if there is nothing in the queue, the consumer thread consumes stuff from the queue in this case. So if the queue is empty, there is nothing to consume. Therefore, we have to wait. And then if some other thread adds something to the queue, then it might has to wake up the consumer. So it adds something to the queue. So in this case here, it just adds something to the queue, and then because it added something, it's going to do a notify1, potentially waiting up anyone who was waiting. This is the general idea. If the queue is empty, we don't have anything to do, so we have to we lock this. You have to lock a mutex. Call this wait, which will go wait and atomically waits and unlocks a mutex. There is a reason that this thing should have locked a mutex shortly before calling notify1, but okay. That's another story. And now here we're doing the following. We are not calling notify1, despite that we are added something to the queue. If waiting is 0, so we load waiting. If it is 0, okay, not larger than 0, then we don't do anything. Which would be good if... Yeah, well, if you did that while this mutex is locked, but then at least you have to lock a mutex every time. This code does not have the mutex locked. It only locks it here. It does not lock it before loading as idle. So it could be loading whatever. It's even a relaxed thing. You don't know what it reads. It could load the variable of the value from yesterday with the relaxed thing. It just loads something. But again, more realistically, it could be loading this and get 0 while this thread is, yeah, well, still before that one. So it's somewhere here in between. And then it already has 0, so it is not going to do anything. But in the meantime, the other thread is adding something to as idle and then waiting. And then it waits forever because yeah, Notify1 is not being called. That's why you have to do a very short lock, at least. It's not necessarily keep the lock while you call Notify1. But let's say here we just make a new scope around this. We just lock it and immediately unlock it, right? That would be good enough. Then it's not possible that you call that you miss the call to Notify1, even though it happens. Also, something that everyone always gets wrong. But this, I also have an answer somewhere on Stack Overflow about that. But this is not good. It's more like, let's say we take the log, we increment it, then we read this, and it is larger than 0. Therefore, we go in here, and this, I think it replaces waiting with waiting -1. So it subtracts 1 from waiting. So now waiting is 0 again. And then we try to lock it, but we cannot because this thing has it locked. Then we go into wait, going to wait, which means that we will see the Notify1, and unlocking the mutex atomically, like I said. So now we can get the lock and call Notify1, and that will wake this guy up. That's why it was correct to decrement waiting already. So this one increments it, and here it is decremented. But as far as I can see it, it's still possible that we wait and don't get a notify now. However, that would only cause a hang if there is no new anything added to the queue. If you assume that there are multiple producer threads that are non-stop producing stuff, then this is not a problem really. Then it could be that you just, you read 0, you don't do anything. This thing blocks, thinking that there is nothing in the queue, while in the meantime there is something. And yeah, well, too bad, until the second thing is added to the queue. At that point, it will still wake it up and then we'll continue. So it's probably not going to be that bad. But it's different in my primes case. In my primes case, we have really everything just fits precisely. You can't miss one thing and then wait for, well, there's just something else to be added. I don't think so. Well, at least it could go wrong indefinitely, and you wait indefinitely. (17 to 22 microseconds. That is a lot. Yes, you do. No, reply there. You do need that lock in this case, or it is possible that the call to node 1 gets lost. Consumer thread could increment as idle, and because of that, but before it entered wait, a producer thread could call notify 1, which wouldn't do anything because there isn't any thread waiting. Then the thread that incremented as idle would enter wait. What I want is that as idle really reflects the exact number of threads that are waiting, that can potentially be woken up. That's what the mutex is for. Note that I leave the mutex out. Timings don't change, it's not causing a delay. If I leave the mutex out, the timings don't change. Oh well, I don't know. I'm gonna add a comment. It's almost midnight. What shall I do? What shall I do? Okay, so let's just be smarter than myself from 5 years ago. Have a quick look here though. This is a test. Yeah, well, bleep. I need threads to do something. What is this weight made of anyway? That's this one, right? So we do have a log here. Is the buffer producer music? Is that a log? It's already logged. Oh right, okay. Okay, because the log is already locked, I can do my as idle increment also before this function. And it's actually interesting that it is already locked. So which log is that? Producer mutex. Uses mutex and producer mutex. Used to wait until the buffer is not full anymore. Yep, constructor of producer access locks it, and the destructor of producer access unlocks it. So it's just the existence of this object called producer access, which is what this thing is returning. So we have a critical area that starts already here. I wonder if this thread or this task is running with or without that lock being locked. I mean, we do move in, and then is that going to run ever, or do I first have to leave this again? I'm not sure at all. Say move in, buffer move in. Yeah, move out. I think this is just a lock-free algorithm. Oh. Oh, that's a notify one. This is the one that should be called then. What the hell is going on then? See, this is the producer access object constructed from this pointer. That would be this one. Buffer. That is calling another lock. Confusing. No, okay. It just uses the mutex of the buffer, and I want it to be locked while I call notify one, and then we call notify one, which then calls notify one on the buffer. So that should wake up anything that is waiting on wait here. I should build in a low watermark here, I think. At least, yeah, configurable. Because this now calls thus notify one immediately, as soon as it removes even one thing from the buffer. And like I said before, it would probably be more efficient to only do that once the buffer was full, and then drops below half or something. But yeah, I don't see it, because it seems to me that this already should work then. But yeah, no, I don't understand it exactly. I can try to add debug output, I guess. See who is first. It's almost impossible to debug. This is code that should just work, you know. That's why I'm really trying hard to write code like that just works. Yeah, I'm afraid in the department of it should already just work. And now I'm looking at it and it turns out that it doesn't work. And then we have a problem because I wrote it a while ago. Let's add some debug output, which is too much to stopping it from not working because this takes too much CPU. Well, yeah, I've got to do something. Yeah, if I don't flush it, then I can't. No, that's horrible. This. I would need a mutex around to see out. Well, this is the main thread. Okay, well, maybe at least I can try to see if. I really don't know what to do. I think it should just stop. Maybe tomorrow I have better ideas. Yeah, has to be expected. It's not going to hang anymore now. A trick in this case is often that you then not write debug output, but store the history of what is happening into some static array. And then when it hangs, you can read out the static array with the debugger and then see what happened. Instead of writing it to terminal. But that's more work. Especially since this involves threads. It's not waiting a lot. Not waiting at all. So because now I let it print output, it's so slow that the threads, the tasks that it starts, already finished by the time it tries to add more to the queue. So the queue is never full, because this is too slow. Now I could try to have the tasks themselves also write something. And then maybe they become so slow again that that the queue does run full. But yeah, not really. Let's reduce the size of the queue drastically. That would help as well to make it full a lot faster. Still works. Did it already print out when we were waiting? Yes, yes I did, right? Interesting. See, now it hangs because I'm not writing all the output. So maybe I should write to a file, and then it's already fast enough. This hangs. No, it does not hang. Shit. It did not hang. Now it hangs. But I didn't flush the debug output, so we'll never know if it wrote everything to the output file. Probably not. So this still doesn't tell much, because if you now look at this file, then yeah, well, that's the last thing that was flushed. I'm going to bed. I'll think about it. Maybe I'll have new ideas before tomorrow, and then I'll try that. Could you look into a keylogger to better understand your live coding? You mean that you can see on the screen the keys that I press? How would that help? Usually, you know, if I type any key, you see it because it appears. Yeah, okay, but how would that help then? I mean, in general, I type, well, okay, the things that you don't see is the VI commands. I guess, so if you go to file, so we go this, and it's KKKKKKKK, dollar, K, 0. You want to see those. Because if I type O and go into insert mode, then you see everything that I type. U, U, or U is that? U. Okay, and then you need to see more than one, I guess. If you just only see the last character that I typed, then it's going to be so fast you won't be following it anyway. Yeah, well, I'm not a whiz in VI or Vim at all. I use a very limited number of commands. Very limited. I think you will probably learn much faster to just train with your own Vim than watching me typing with a keylogger in the corner. Yeah, there's a queue. Well, okay. And how would I find that for keylogger? Sounds like someone steals my password. That can't be it. Maybe for Vim itself. Vim keylogger or nah. I mean, keylogger is not the right keyword here. You have to type in something that makes clear that I want to show it. To show the keys, a key shower. Not working, I don't see it. Yep. Strange. Seems to be saying that it does. Displays your keystrokes in the status line. That's what you want. Why does it not work? This didn't work for me in a vanilla Vim. Even when after running. Try it again. Status line is 2. Doesn't change anything either. No show command. Oh, wait a minute. I want to do the opposite. Show command. Nope, still doesn't show my commands. But okay, we have something to look for now. So show pressed keys, Vim onboard status line. So status line, pressed keys, and maybe something related to show command. What is show command? I did try that already. maybe it just doesn't show every command. This is only talking about visual mode. The number of characters. Seems like something totally different then. Oh yeah, so here. The 3 times 32. That's what it does. That's not what we are looking for, I guess. So it's only showing the number of lines that you select. I want to really have the full show command. Dude, what the hell? So mode, show top line, show side scroll. There's no other show anymore. Hey, we have ChatGPT. Let you know. Yeah. Well, I don't know, man. I'm going to bed. If you find out how to do this, then tell me. I'm willing to show the keys, but I don't know how to do it. Display keys, press and Vim. I tried set show command, but it doesn't work. No, we figured that one out. It's just not true. This is just not true. Bullshit. Nope, I give up, dude. Sam says, what allows for... You have a cat? I like cats also. I don't have a cat though. I just like them. Yeah, I would answer your question now seriously, but I really cannot. I see operating system, but the no. And I'm going to bed. I'll see you tomorrow.